Alright, we have our tests. I'm pretty sure I probably made some errors here while doing that, and you probably noticed those errors and we're like, Jamie, oh! And anyway, don't worry about it. I'll fix it. I'm trying to come up with a different name here because now it's not Matrix3D anymore. It's like Matrix3D and Matrix2DH. But I can't come up with a better name, so I'm just going to let that hang for now. Math, Matrix, 3D. I'm going to copy and paste this, but last time I did a copy and paste in Visual Studio like this, it didn't work out very well, so I'm actually going to open the folder in Windows Explorer. Just bring this into view there, and it's in the engine, in the math, Matrix 3D like this, Control C, Control V, F2, Matrix 2DH, and F2, Matrix 2DH, enter. Let's just add these while we're at it. Tortoise SVN, you can't see it off screen, but I'm clicking add that to my repo. Come over here, refresh, you can see they're here, so now I'll right click there and say, hey, include them as well. And since they're header files and inline files, including them really does nothing as far as compilation goes, because we will include them and into the compilation units. But still, it's nice to have them part of my working project here. Anyway, Matrix 2DH. Let's open this up, and essentially Control H, replace Matrix 3D with Matrix 2DH. Replace all. One occurrence replaced. What? Oh, it searched the selection. Let me do current document. Okay, replace all 8 occurrences. That's much better. Let's go to 2DH and do the same thing. Replace all. Very good. Now, here's the kind of hack and slash. Remember, we don't have this last row. Let's eliminate that last row. And we'll eliminate that last row here as well. We have a rotate still. We'll have a translate. We're going to have a multiplication against a vector 3D. That's correct. And we will also multiply two matrices, Matrix 2DH against each other, return a 2DH. So this file, I think, is good. Now let's go grab the inliner file there and look at that. Again, don't have the last row anymore, so eliminate that. Don't have this anymore. Eliminate that. We still have the rotate. I believe that might be IntelliSense just having problems. Oh, no, we don't have this last row anymore. Remember that? In fact, look at that. The defaults are 0, 0, 1, right? We're going to just assume that when we do our multiplications here. So there we go. Get rid of those as well. Matrix times a matrix. Again, basically everywhere we see a row 2, we no longer have anymore. So what is this? Multiply against the vector here. Well, if you remember, we no longer need this multiplication and the addition and multiplication. We're eliminating all these operations, right? All we're going to take is the z value of that last vector. So this is where the optimization happens. We no longer need that. All right, and then we're going to gain some optimizations here as well. But just looking at this, I'm realizing I made a mistake in my unit tests here, because how many times have I multiplied a matrix? Yeah, I can't believe I screwed that up. You probably noticed that when I made my unit test. So let's go back into the unit test for matrix, or there's a matrix 3D test here, where I multiply a matrix against a matrix. Right here, if you remember, I eliminated the last row, but it's also going to affect these values as well. All right, and how is it going to? I'm going to first of all save all these files. Control Shift S. Well, how's it going to affect those? Let me grab my drawing tool here. And I'm going to draw the 3 rows here, because remember, when we're the matrix on the left, we take the rows of it, and the matrix on the right, we take the columns of it. So this matrix times this matrix gives us a result of this matrix. Okay, and to get, just popping back to the tests here, or not the tests, the implementation here. Let's just take this first row, first column. So this cell right here, well, to get that cell right there, we need to take the first row and multiply it against the first column, which means in this case we were actually including the 7, 8, and 9. That would modify the value here, but we no longer have the 7, 8, and 9. So how are these values going to change? Well, we can either work backwards or we can work forwards. I think it's probably just easiest to work forwards, so that's what I'm going to do. Let me just, first of all, for my sanity, let's start over and eliminate all these and clear the board off. Let me just draw these matrices as they really are. All right, 1, 2, 3. And if you want to work backwards offline, that's fine. But and this might be a little slow for you. Sorry if it is. I'm kind of one that, well, I noticed I've been doing some programming with my son, and with him he's pretty young still, and with him I've had to really kind of lay things out very slowly for him. But he's picking it up, which is really cool. He's making me proud. But laying things out for him in pretty excruciating detail, nice and slowly, it's the closest I've been to being an engineer. Right? We always call ourselves software engineers, and I actually think that term's a joke, because we're not software engineers. Let's be honest, we kind of hack and slash, don't we? We kind of, oh, that didn't work. Let me, boom, try this. Oh, that didn't. Oh, I call it shotgun programming. Oh, what happens if I tweak this? Boom. Oh, that didn't. Oh, well, let's try this. Boom. And we keep kind of just throwing these guesses out there, and then finally we stop and start to debug, and we're like, oh, okay, let me actually think about this, see if I can figure it out. And and I'm I'm a software engineer for sure, and I feel much more like an engineer when I do my unit tests correctly. But when I'm just in there kind of working the numbers and not really thinking of it, I'm shotgun programming at that point. And anyway, with my son, I've had to do some excruciating detail and actually engineer the programs before I write them. Go figure. I had to think about what I was doing before I actually did it. So I need to do more of that. And let's do that here. Well, you can see I didn't even think about it before we did it. I just kind of assumed these would work, and then realized when I was back in unit or implementation land that these values weren't correct. Okay, here's our resulting matrix. So to get this value here, we're going to multiply this row against this column. So 1 times 1 is 1, plus 2 times 4. 2 times 4 is 8, plus 1. That will give me a 9 here. Alright, let me just put a 9 there, and then let's do the next value. Well, this row, this value right here, is going to be this row times this column. So 1 times 2 is 2. There's a 2, plus 2 times 5 is 10. That will give me a 12. Alright, let's put our 12 there. Okay, notice though it's kind of easier. I'm only having to consider two values, right? One multiplication plus another multiplication. So really two multiplications is all I'm worrying about, because I got zeros down here. I can forget about it. And again, I'm mentally taking the steps that the processor is going to take. We no longer have to worry about that. Okay, to get this value here, it's this row times this column. So 1 times 3 is 3, plus 2 times 6 is 12. So 12 plus 3 is 15. Look at me doing all this in my head. I'm bound to make a mistake. 15 plus 3 times 1 will make an 18. Okay, there's the 18. So let me actually put these values in here. 9, 12, 18. Okay, let's do the second row here. Well, it's going to be this row times this column. So 4 times 1 is 4, plus 5 times 4, 20, so that will be a 24. Alright, this row times this column. 4 times 2 is 8, 5 times 5 is 25, 25 plus 8 is 33. Alright, this row, this column, 4 times, I'm going to write this one out. 4 times 3 is 12. 5 times 6 is 30. There's the plus there. And then 6 times 1 is 6. So 36, 37, 38, 48. Alright. 48. And then we don't have this row there. So let's get rid of that temporary stuff. And I'm just going to put these values down in here. And maybe I screwed up doing those numbers. That's another thing about watching my son. He generally doesn't screw up doing multiplication. In his head, I screw it up all the time, but it's fascinating for me to watch my son. He's really good at it. If you want to see more interactions with me teaching my son, I'm teaching him in the assembly, and so that's where the assembly programming playlist is coming from. Okay, I hope we have that right. Let me just put that away for now. Matrix2D. Where were we over here? We were essentially eliminating this multiplication. So eliminating this multiplication, to work backwards, if I wanted to, I could have taken in the unit test here, and it probably would have been faster. I could have taken the end results that we had over here and subtract out this last multiplication. In fact, I'm tempted to do that to verify that my math is correct down here. You're probably saying, oh, Jamie, come on, unit testing's so boring. Well, if it's so boring, why don't you just skip this video? So let me be the engineer and actually work backwards now, just to double check that my values down here are correct. So I have, can I bring that back up? Let's do this. What is, actually, yeah, I will bring that back up. Let me write in the other values that we had here. I'm going to write them in red. Hopefully they show up good enough. Let me use just a little bit thicker. So here's the 7 that we originally had. Here's the 8. And here's the 9. So to get this, let me go back to blue. To get this value here, it's essentially this value minus the last operation that we had previously. So we had a 3 times 7, and we were adding that in. But now we need to take that out of what we have here. So 30 minus 3 times 7, which is 21, gives us 9. Good, I'm feeling good about that. We got that one right. Alright, so let's do the 12 here. Well, how do we get the 12? Well, 36, what do you have? To get the 36 represents this cell right here, the 12, which would be this row times this column. So 3 times 8 is 24. 24 times 36, or 36 subtract 24 gives us 12. That's right. Very good. So we got that one right. See how I'm working backwards now? I worked forwards, and now I'm working backwards. And really, if I wasn't doing this on a video for educational purposes, I'd punch these values into my TI-82 and look at the results of the matrix multiply and just go off what the calculator was giving me. That's certainly a valid approach or attempt. But I think it's important to understand the math and why the math is here. And remember that I'm doing this whole playlist for educational purposes. So if this is beyond, or not beyond you, but if you're beyond it, then feel free to skip it. Okay, 42. How do we get the 42? Well, it's this row times this column. So I'm taking out the 3 times 9. And instead it's going to be a 3 times 1. So that one's a little more interesting. We need to take out the 3 times 9 and then add a 3 times 1. So 42, let me just put it down here. 42 minus the 3 times 9 is a 27. But then we need to add the 3 times 1, which is a 3. Oh, how are we going to do this? Let's first add the 3. So instead of 42, let's do a 45. And then get rid of this. And then 45 minus 27 will, or yeah, 45 minus 27. 7 from 5, well, we have to do the carry, so this will bring this down to a 3. And then 15. 7 from 15 is an 8. And then 2 from 3 is a 1. So that's an 18. Oh, look at that. 18 and 18. So I got that one right as well. All right, good. Good. All right, well, hopefully you're seeing the process I'm going through working backwards here. I'm going to do it for this one. Alright, these values I'm going to work backwards, but I'm going to leave that as an exercise for you to do offline. I'm not going to do it for you. But in the next video, we're actually going to move on with this, see if we can get this compiling and the tests building.